Lesson 14. Deadweight and holds capacity. 14.1 Introduction. I deliberately started the basic course with the main thing, with stability criteria, and here's why. If you do not know how to calculate your landing and stability manually, this is not so bad. In the end, everything is calculated by the cargo computer. The trouble is if you do not know how to evaluate what he counted. I hope that the first part of the course, passed by us, will help you with this, and you will be able, looking at the final table and the static stability diagram, to draw a conclusion on the stability, the readiness of your vessel for a voyage. The second part of the basic course, which I begin with this lesson, is planned as a step-by-step instruction for a cargo officer in loading and unloading his iron. The goal is to teach a seaman who has thoroughly forgotten everything to manually calculate his landing and stability from zero, that is, from the moment he received the order task for the voyage. My deep conviction is that everyone who respects himself as a chief officer should be able to do this. In this part, I will load a small bulk carrier, which will allow us to consolidate the material covered. The cargo is an abstract and non-hazardous bulk. Now it is important to learn the loading technique and its algorithm, in which the specifics of the cargo and the size of the vessel are not important. Specialization in cargo is planned in separate courses. 14.2 Cargo Plan. Loading Algorithm. Calculation of landing, stability, and strength of the vessel is carried out in several stages. Stage I, finding the net deadweight and cargo capacity of the vessel. Determining the possibility of transporting cargo of order tasks. Stage 2, preparation of the cargo plan as a first approximation. Stage 3, finding the coordinates of the center of gravity G, comparing the found kg with the allowable kg, determination of the ship's draft and trim, its metacentric height, taking into account the influence of free surfaces, the first assessment of stability. Correction of the cargo plan if necessary. Stage 4, calculation and drawing of static and dynamic stability diagrams. Stage V, assessment of the ship's stability for compliance with the stability requirements and IMO criteria. Correction of the cargo plan if necessary. Stage 6, assessment of the local and overall longitudinal strength of the vessel. Stage 7, approval of the cargo plan by the captain is an official document for action and the beginning of cargo operations. In this lesson, we will look at Stage I, net deadweight and cargo volume capacity. Drawing up a cargo plan, Stage 2, a separate topic and will be discussed further. Calculation of the net deadweight and cargo capacity of the vessel for the voyage. Shio's details Yun partisan is on your screen. For the sake of brevity, I will only mention a few of them. Length, 80-35. Width, 12,8. Summer displacement, 3,947 tons. Summer deadweight, 2,180 tons. Summer draft, 5,2. Range, 4.000 miles. Operating speed, 12,84 knots. Order of the charter or simply, order task, transport the maximum amount of bulk cargo, with a stowage factor 1.3 cub.m/t, from port A to port B. Distance from berth to berth S equals 3,300 nanometers. Start of the voyage June 7, 16. Note 1. Usually, the order task contains the question: can you take some cargo at point A and transport it to point B? Next comes the characteristics of the load. After the calculation, you must answer this question. 2. Grain is dangerous due to its fluidity. Its transportation falls under the regulations of the Special Grain Code 91, but at this stage of training, this cargo will be considered as a non-hazardous bulk. 14.3.1 Voyage length calculation. The duration of the voyage in days is calculated using the formula, 14.1. Calculation result equals approximately 11 days. Where S equals 3,300 n.m, the length from berth to berth. Vs equals 12,84 knots, operating speed. 14.3.2 Calculation of fuels and lubricants, fresh water and food for the voyage. 1. The required amount of fuel for the passage is calculated, formula 14.2. Result equals 128,7 tons. There are 152.4 tons of fuel on board. That there is enough for the voyage, without additional bunkering. 2. The stock of lube oil is approximately 4 divided by 6% of the stock of fuel in tons, formula 14.3. Approximately necessary 7 ton for the passage. There are 16.7 tons of oil on board and the chief engineer confirms the sufficiency of both fuel and lube. Oil. 3. The supply of fresh water for the needs of the crew for the voyage is taken 100% of the volume of fresh water tanks, and the minimum is determined from sanitary standards, 70 divided by 100 liters per person per day, formula 14.4. We need 8.8 tons of fresh water for 8 persons of crew. According to good marine practice, we bunker with water up to 100%. There are 61.8 tons of fresh water on board now. 4. The minimum required supply of provisions for the crew is determined based on the norms of 2.5 divided by 3 kilograms per person per day, formula 14.5. We've just replenished our provisions. On board 3.5 tons, enough for the voyage. 14.3.3 Calculation of net deadweight and volume cargo capacity for voyage. 1. The first limiting factor is determined, the net deadweight of the vessel, which is equal to the difference between the summer deadweight for the summer load line, or your zone, and all ship bunker and stores with constant, that is, the total cargo in tons that you can take on board on this voyage, formula 14.6. After deductions, we have net deadweight equals 1895,46 metric tons. Asterisk according to the zone and seasonal area and the date of departure, the permitted load line, midle draft, for your vessel is determined. Constant, subject of draft surveys before loading, total weight in tons of all other unaccounted loads. According to the charter order, the loading was completed in the summer, August 6, 2016. The navigation takes place in the Black, Mediterranean Sea, summer zone. The length of the voyage is 11 days. Conclusion: the summer load line is in force throughout the voyage. This means that I can load my steamboat under the S-load line, provided that the sea water density is standard, 1.025 T/M3. This is what will happen when I take on board the calculated amount of cargo of 1,895.5 tons. Load line note. Both the displacement and deadweight of the vessel given in the ship's particular and other documents are given in summer, letter S. This means that the vessel is in the summer zone, the dates of which are presented on the map of zones and seasonal areas. When fully loaded, will sink along the upper edge of the S grade, subject to a standard sea water density of 1.025 T/cub.m. If my ship is loaded in the Black Sea in summer, as in my case, then when taking full load capacity, DWS equals 2100 tons, my load line S will be sunk, since the average value of water density in the summer Black Sea is 1.016 T/cub.m and no any port authority will have any claims against me after the presentation of the cargo calculation. If, more than expected, the ship ends up in the Chernaya River, for example, on additional loading, with fresh water, 1, then I will sit down to the upper edge of the next TS mark, because both tropic and fresh are approximately on the same level. The explanation is simple: the water in the tropical zone has a high temperature, so its density is close to the density of fresh water 1520 degree. The highest grade TF, tropic fresh, for high temperature fresh water, denotes the smallest freeboard. The ship, with my load, will fall through this mark, in a tropical river, for example, in the Congo River. The letter W, below the summer one, means that I have to ship my hardware for this brand in the winter zone. You will find markings and dates on the same chart of zones and seasonal areas. In winter, seawater in this zone has a low temperature, which explains its higher density. Theoretically, I, with my load, should climb the upper edge of the winter mark if I find myself in February, anywhere in the winter zone, in one of the ports of Canada. This is theoretical. Be careful in the calculations, the deadweight of the vessel varies slightly for different brands. WNA, Winter North Atlantic, the lowest mark, determines the largest reserve of buoyancy, freeboard. The North Atlantic in winter is a special area, dangerous with frequent storms and possible icing, therefore, when operating a vessel in this area, I am obliged to comply with this mark for safety purposes. 2. The second limiting factor is determined, cargo capacity by the total volume of cargo holds and tween decks, Formula 14.6. The total volume of holds is 3,210 cubic meters. 14.3.4 Comparison of limiting factors with charter order. 1. Compare the net deadweight with the cargo weight of order task and it must be less than or the same. According to the order task, I take the maximum amount of cargo. In terms of weight, I am limited by my carrying capacity and can only take 1,895.5 tons. 2. The volume of this cargo is found. Weight multiplied by stowage factor will give the volume of cargo, which is equal to 2,465 cub.m. Where, stowage factor 1.3 m3/t, specific loading volume, the number of cubic meters in 1 ton of cargo. 3. The volume of the cargo space must be greater than or equal to the volume of the cargo. This condition is met. Conclusion: the capacity of cargo holds does not limit us in any way. After loading will remain 745 cub.m of empty space. General conclusion: the ship can transport 1,896 tons of bulk from port A to port B. Summary: 1. The vessel is limited for the carriage of cargo by its net deadweight and volume cargo capacity. 2. Net tonnage per voyage equals the difference between summer deadweight and all ship stocks with constant. 3. Volume cargo capacity is verified by comparing the total volume of cargo holds with the volume of cargo. 4. If both conditions are met, by weight and volume, the charter cargo can be stowed on the ship and transported for this distance. Good luck.